Right, so let's talk about integers now. So first, integer data type is byte, which is 1 byte, also 8 bits. The byte data type can store whole numbers from -128 to 127, positive 127. The other one is short, which is 2 bytes, also 16 bits. And the short data type can store whole numbers from negative 32,000 to a little over positive 32,000. Okay, so and the one that is the most commonly used is int, and integer. Int is a 4 byte number type. Uh, also is 32 bits. So the int type can store whole numbers from little below negative 2 billion to 2.1, roughly 2.1 billion. So, and this is the most commonly used. However, in case of this number is not big enough. We could use long. We'll hardly use this in class, but it is something you should definitely know. The long data type is an 8 byte size and can store whole numbers from basically this number to this number is too huge to even try to say it. So it's pretty long. So this the whole thing may tell you one thing, that the numbers are not infinite in any programming language. So they have a size, and in order to correctly calculate any type of arithmetic, you need to make sure that you use correct size, not too big, not too small. Okay. If you use something too big, that means you're using too much memory. If you're using something that's too small, that means you're getting calculation errors. So with that, let's see an example in the editor. All right, everyone, let's do our first example. So as we did this last week, first thing I want to do is on my terminal window, I want to see present working directory. I want to see where I am. Then I can do ls to see where I can go from here. I can go to my desktop. So to do that, if you remember, the command was cd space and the folder name or the directory name. So on my desktop, I can do another ls and see a bunch of folders or directories are here. And I can, this is my go to directory for this semester. So I'm going to say cd cis 36 and list again. So if you remember, we had a folder from last lecture. Now we're going to create one more. So I'm going to create a new directory. Of course, we can just go in here and then right click and say new folder. But I thought it will be more interesting to see from the command line. So mkdir is a command for make new directory, and the name will be lecture 2. And there you go, you see the folder right here. Then I can say cd lecture 2 and I'm in. So let's see what I have in here. Of course, nothing, so nothing to display. One command that we never practiced with so far is a cd space. As you can see, I am in lecture 2. If I want to go up one level, I have to say cd space and dot dot. It will take me back to 36. So this is where I am now. So to go back in, so we can say cd space lecture 2 again, and I'm in. So let's get started. In our first example, I'm going to save this one as, of course I have to navigate. They can't do this with command line. So this will be inches.java. So last week we learned about .java and .class extensions. I hope you are familiar with it now. All right, so class inches. So one thing I'm going to do is, as I said last week, I'm not going to type up public static void main. All I'm going to say main and hit tab. There you go. So this is the shortcut, so you don't have to keep typing this. You just say main enter or main tab. You will get your main method created for you. So next I'm going to create two variables. This time, so we did some integer examples last week, so I'm going to do some long examples. Then I want to change it back to int and see what's going on, why we're not using int and we're using long. So I'm going to say cubic inches. This is my first variable. My second one is again another long. This one will call inches per mile. As you can see, I'm using camel case for my variable, and that's a that's one common convention. You can also say cubic inches with underscore in between them. It's also perfectly acceptable. So what I'm going to do is I'm going to calculate inches per mile. So what is inches per mile? Inches per mile is 5280 times 12. Okay, so in each feet or foot there are 12 inches, so 12 times 5280 feet basically in a mile. So we got inches per mile. Now we're going to say cubic inches will be inches per mile times inches per mile times inches per mile. You can already figure out that that's gonna be a very, very big number. So if I want to print this first, just print system. Should I print it now? Yeah, system. So to quickly type system.out.println, all you have to say is pl tab or hit enter. So then I can say there are plus inches per mile, inches in a mile. So just to see what number this is, and then we also calculated the cubic inches. So let's print it out as well. So again, I'm going to say pl tab to quickly type out this. Then I'm going to say there are plus cubic inches plus say space cubic inches in a cubic mile. It's kind of short, long sentence, but we're done. Here you go. So I'll zoom out a little bit so we can see the whole thing. Right, so let's compile. Again, remember our three basic steps: save, compile, and run. So I'm going to save. To compile, I'm going to say Java C inches.java. If everything is good, we got that. So Java inches. So first there are this many inches in a mile. So I should correct this. Inches in a mile. So I forgot to say that. And second is there are this many cubic inches in a cubic mile. So you can tell this is already a number that's a lot bigger than 2.1 billion, which the limit of the integer. So that's why we use long. Long has a bigger number set that can easily hold this. So after the, let me recompile and then run again. As you can see, looks good, no problem. But if I were to, here's what might happen. If I were to go ahead and change this to an int and change this one to an int, and So then let's compile and run, and let's see if you see anything that doesn't seem to be correct. First of all, there are this many, I'm not gonna read it out, inches in a mile. Seems okay, not a problem, matches this finding that we did, but notice that this is different. So it's even smaller, okay? What really happens here is that since integer is a small set, anytime we create a calculation that actually exceeds the limit, we get what we call overflow. So numbers will overflow, and then it will show something that is not correct. So that's why we had to use long. There you go. So you can compile this and run again. We're back to the correct value. Okay, so that was a quick example for integer variable types.